We're going to talk about flow networks now. So this is a type of graph, and we're going to actually talk about max flow problems. All right, it's abbreviated for maximum flow problems. All right, so in many ways, this is you can think of this as some sort of game where you have to try to win, find the maximal outcome. The good news here is before we get to, or the news gets bleak, you can actually find a maximum flow in every case. There's a fairly straightforward algorithm with which to do it. We just have to develop mechanisms to get there. Alright, so a lot of terminology that goes with this. It's kind of a layer of terminology on top of things we already use. So this is a fairly extensive definition, but a flow network is a directed weighted graph. So not only does it have directions, but also has weights. With a single source and sink. Okay, this is pretty typical for the way I like to define things. Of course, what's missing here is source and sink. We'll define these shortly. All right, let's go ahead and do them together as definitions. A source is a vertex with n degree equals 0. Everything's going out. A sink is a vertex everything comes in, so out degree is equal to 0. Okay, and I'll draw a picture of this in a moment. Anything else is called a node, N-O-D-E. Okay, this terminology is consistent with what's used in differential equations. There's the notion of a sink, source, and a node in differential equations, and this is the same definition used there. Okay, and same thing with flows. Flows are used in dynamical systems and differential equations and in a few other contexts, but it's all related to one another. We're doing a discrete format of that, which adds a lot more simplicity to the situation. Let me draw some pictures of sink, sources, and nodes, and then an example of a flow network. So let's do a source. All right, so a source has everything going out. And when we do a full flow network, these will have numbers as well. So this is a source. Sink is going to have everything coming in. Let me just maybe do something slightly different looking, but everything has to come in for it to be a sink. Right? And maybe it's just one edge coming in, or maybe it's 5 like I have here, or 500, or 2. Right? And then a node is going to have some edges coming in, and some going out. We do a whole bunch going out there for fun. So that's what a node would look like. Okay. All right, so let me show you an example of a flow network. We'll identify the source, the sink, and the nodes. Right, so this will just be small. These things can get quite massive, which makes these problems fun. All right, commonly, but not universally, I'm going to put the sources on one side and the sinks on the other, and try to keep the nodes in between. So I'm just going to make sure I have all the edges I think I do. Okay, so you can see that is a source. here is a sink. Let's give these some names. A, B, C, D, E. And because there's so much green, let's do the weights in another color, because these are going to have weights on them. I'm not going to do anything with these weights in this video, but we will in subsequent videos. Okay, we'll have another name for these weights shortly. Okay, so A is the source, B source needs to be singular for this to be a flow network. E is the sink, and B, C, and D are nodes. Okay. There is just a single source and a single sink, and so this is a flow network. Okay, there are ways to patch things. If you have multiple sources and multiple sinks, you can unify them into a single source and a single sink. We'll show that much later, but so it is possible to patch them and make something that has potential to be a float network into something that is. However, if you are lacking a source or lacking a sink, that is where things become more complicated. You have to sort of artificially introduce where's your source flow going to be and where's your sink going to be, and that can have big downstream problems based on what you're doing. So it just depends on your application. There's a lot of natural flow network problems that don't start as a flow network. You actually have to build that infrastructure around it. And one example of this is with scheduling problems. So if you are somewhat familiar with scheduling problems, they don't start with a source and a sink. That's something you actually have to put externally onto it and then work from there. All right, so anyway, this is a good start for flow networks. We have the basic names of the vertices of different types. We know that they're a directed weighted graph. What we're going to work on next is the names of these weights and the rules of the flow game. Okay, so how we put a flow onto a flow network. As of now, this thing actually has no flow on it. These weights do not indicate flow numbers. All right, so keep that in mind. The flow network may or may not have flow on it. And as of now, this one has no flow. Okay, so we'll start working on it in the next video, and I'll see you on that one.